Ready to get started with video over fiber? This presentation will provide a short overview of the technology behind these options, as well as an overview of the different types of solutions so that you can choose the right video over fiber system for your application. The primary purpose of a video over fiber converter is to convert the electrical signals to optical and then back again. The goal being that you just plug in the electrical connectors and all this conversion is done in the background. There's four key components in that system. There's a driver, which converts the high-speed signals to something that can drive a laser, which is usually a VCSEL, a small low-power laser in the system, which then goes to a photodetector that converts the light back to electrical, and then there's a transimpedance and limiting amplifier in the system that converts that small electrical signal back to a much larger one that can drive the system. HDMI signals are transmitted in a variety of ways depending on if the lasers are all run over different fibers or if they're multiplexed onto a single fiber, and whether the low-speed channels of HDMI are run over fiber or copper. So the most common option that's used in active optical cables is a parallel fiber hybrid cable, which is shown down here in the lower left. This transmits the high-speed signals, which are the most susceptible to signal integrity and EMI, over fiber, and leaves the lower speed signals such as your DDC, hot plug, CEC, all over copper. This cable is cheap and easy to make, but the connection to the optics has to be done in the factory. You can't cut this cable and terminate it in the field because there's 4 fibers and then 5 or more very, very tiny copper wires that you just don't want to be terminating that in the field. The second type that's seen out in industry is an all-fiber system where the high-speed lanes are done over 4 separate VCSELs, and then there's a low-speed lane that's also done over fiber for the control. This requires a microcontroller to handle the multiplexing and demultiplexing of those electrical signals. This fiber cable is all fiber, so you get all the benefits of fiber, such as immunity to electromagnetic interference and the signal integrity. You can transmit over very, very long distances with this. But this solution also cannot be terminated in the field because there's anywhere from 6 to 12 separate fibers, and if you're going to put them into a single fiber connector, you need to very, very carefully align each fiber to one another to make that connection. The third option is multiplexing the optical signals onto 1 or 2 fibers, and this is generally done for when you see SC and LC connectors in the field. So there may be 1 or 2 SC or LC connectors, and they use wavelength division multiplexing so that just a standard fiber cable can use. So what is wavelength division multiplexing? Well, this allows you to put, really if you want to, all of the HDMI signals onto just one industry standard fiber. So special optics are used to combine different wavelengths of light onto a single fiber so that you can transmit multiple signals at the same time along the same fiber without any interference with each other, using wavelengths division multiplexing. And you can even go in 2 different directions. So some fibers can transmit one direction and the others can transmit the other direction, and they will not interfere with each other. The benefits of this is that the integrator needs only 1 or maybe 2 fibers, but you can definitely pull just fiber cable and terminate it in the field. And you usually pull 2 strands, so if you only need 1 fiber, that actually provides you one to leave dark and have backup down the road. And it allows for fast and easy integration. So let's look at the different types of optical video interconnects. The first, and like I said, probably most common, is the active optical cable. This is a fixed length cable with the active optoelectronics built into the end. So they plug generally right into your system, just like a copper cable, and may or may not require power. One challenge with these, though, is that because the end is fixed, if you're going to pull it through a wall, you have to pull that whole entire end through the wall, and often we see integrators complaining about the cables getting broken when they're trying to pull them through conduit. And the second challenge is that they have a transmit end and a receive end, and if you pull the whole thing and put it in backwards, it will not work, and you'll have to pull it out and re-pull it. The second type of video interconnect that's very common today are optical video extenders. So these are generally black boxes that support not only your video protocol, but also may do RS-232, IR, or Ethernet for control in the same box. They usually have a pluggable fiber interface, although there's a couple of them that have integrated optical interfaces. But one thing to be aware of here is that if they use a standard SFP+ optical transceiver, SFP Plus only supports 10 gigabits per second, so unless you have multiple transceivers in there or use a 40 gig QSFP, your data has to be compressed for HDMI. The third type of optical video interconnect is the optical adapter. These are plug-and-play components that use standard fiber that plugs right into the adapters themselves, which then plug into the source or the display. The benefit of active optical adapters is that they can be swapped out when 8K comes along simply by changing out the ends and leaving the fiber in the wall. INEOS has two types of real 4K products, an optical adapter and an optical extender. The optical adapter supports HDMI 2.0b, 18 gigabits per second, with any type of HDR up to 1,000 meters, no compression, using our unique CWDM technology, so that all HDMI and CEC is done over one single fiber. So this allows customers to just pull standard fiber in the wall, come terminate it on their own, and plug in the optical adapters when it's time to do the installation. Or if you're not comfortable terminating fiber in the field, you can buy pre-cut, pre-terminated fiber and pull that as well. The Real 4K optical extender not only supports the full 18 gigabits HDMI over a single fiber, but also adds support for the audio return channel and bidirectional IR control. Again, all over one single fiber. So this allows you to do all of the HDR10, Dolby Vision, whatever cool HDR technology that you have without having to worry about that signal integrity and that video picture being compromised using compression. It also allows you to plug in variable lengths of HDMI copper cable to interface with your source and your sink so that you can have a very clean installation depending on where you want to mount your adapter. If you have questions about any of our Real 4K products or optical technology in general, get a hold of us at contact@ineos.com.